not finish for chapter 6 was electricity. How it is that cells maintain an electrical field. And that leads us right into chapter 7. So that's why it's okay to begin to talk about chapter 7, though I probably should go ahead and pull up those slides. Now that I think about it, because I might have gone into a little more detail. Yep. Because now we're ready to talk about the membrane potentials, specifically thinking about going into chapter 7. So this is the end of chapter 6. You notice that the beginning of chapter 7 does an electricity review. And it starts talking about these gated channels and the resting membrane potential. So we'll go ahead and go to chapter 6 and just finish up this little bit. And then we can go quickly through that beginning of chapter 7. This information is also going to be true about muscles. And that's all 3 categories of muscle, because they are all responsive. So they all also maintain a resting membrane potential. And if you've already looked at homework 7, that phrase I just gave you, resting membrane potential, that's the first part of homework 7, is describing the resting membrane potential of a neuron. Though this describes that plus more. So there is an electrical charge between the inside and the outside of a cell. The inside of a cell has those big anions. Remember what anions? They're negatively charged. So it's the proteins and DNA. Both have negative charges on them and they cannot leave the cell. So they make the inside of the cell negative, which draws in a cation. And this particular cation is going to be potassium. Now I looked at why potassium and not sodium. And it's hypotheses about the first cells, that the primordial soup was heavy in potassium. And so that's the thinking, that when the first cells developed, they had potassium on the inside. It's like, well, it's not really a very good answer, but okay. So potassium stays in because the inside is so negative. So if we look at it, what if this pen works? No, not really. So inside we have DNA, we have proteins.